Hey everybody, welcome to part 5 in the lab procedures packet, which is all about handling solids. So whenever you're going to obtain a solid in the lab, most of the time they're going to be kept in a wide mouth bottle that looks similar to this. So this is some zinc sulfate that I just happened to grab from the back, and you'll see that these jars have quite a bit of information on them. So we have the formula, there's the name of it, of course, it's molar mass, which we'll talk more about what that means later in the year. And there's some safety features as well. Everything that we're using in this class is going to be relatively safe for us to use. Of course, if there is any risk of anything, I'll let you know before we start the lab. For the most part though, if you get something on your hands, you just have to wash your hands, which is a good practice for you to do anyway. So when I have a wide mouth bottle like this, we don't want to use our hands to collect this from there. And actually, as I'm working with this, because I have a bottle open, I will put my safety goggles on. Even if it is just salt, it doesn't matter. I don't want you to use your hands to obtain chemicals in our chemistry lab, even if it's just salt. And the reason for that is because we want to practice proper lab safety skills. So in order to obtain a solid from a wide mouth jar, we're going to use something like this. And this is a scoopula, and it has a funny name. The way you spell this is S-C-O-O-P-U-L-A, scoopula. And as you can see, there's really only a little bit of zinc sulfate left in this jar. So if you were to go and try to get this zinc sulfate out, a lot of students will do this and they'll go, oh man, I'm not really getting much of the zinc sulfate out. But the best way to obtain chemicals out of a jar is to do something very simple, and it's just to tilt the container like this. So you want to tilt the container, and so it's on its side. And again, if this is fuller, we don't want to tilt it this much. But we're going to use our scoopula in the other hand, and we can get quite a bit of the material out that way. So we'll use the scoopula in order to do that. When you obtain a chemical as well, it's good to only take the amount that you need. And the reason why is because if you take too much of this chemical, and let's say I have this beaker at my lab table, this beaker might not be clean. There might be some contamination in there from another experiment. Maybe this wasn't cleaned out well enough before. Maybe it was sitting on a shelf for too long and there's quite a bit of dust in there. So if you put all of this chemical into this beaker, and if you don't need all of this, and you pour it back into this jar is now contaminated with whatever else was in here. So we always want to take the amount of chemical that we need and not pour anything back into their original containers, because that prevents contamination. One way that you can weigh chemicals in the lab using the scale is by using a weigh boat. And this is a ridiculously large weigh boat. It's like as big as my face, but you would put this on a scale, and you would zero the scale out, so that way it's not counting the mass of this weigh boat. And you can then put your chemical into here and mass that, and then this can very nicely fold like that. And you could pour that, and then you could tap to get the rest of the excess down into your beaker. Instead of using a weigh boat, we also have Whey Paper, which works the same exact way. This is quite a bit flimsier though. And the same exact thing, you'd put this on your scale, you would put your solid to be measured on here, and you'd roll it up like that to get it into your test tube or your beaker or whatever, and you could just kind of tap the side like that, so that way all of that gets inside. Of course, if you do get any sort of chemicals on your hands in the lab, you should always wash your hands, and that's the best way of preventing from getting any chemicals inside of your mouth, is by washing your hands at the end of every single lab experiment, or even if you're just sitting at the lab table. It's always good practice to wash your hands at the very, very end. And again, that prevents any sort of chemicals from getting inside of your mouth and your digestive tract. Let's say that you're accidentally using something and it breaks. So just yesterday, I was right back there cleaning a whole bunch of beakers and flasks and stuff, and I was picking too many of them up, and one of them fell on the floor. And luckily it didn't break. I was very surprised that this beaker just kind of bounced on the floor like a basketball, and it didn't break. But there will be instances in here in which we will have broken glass. And if you do have broken glass, you do not want to touch that with your bare hands. It's always best practice to use a little brush like this. So I have a couple of these dustpans in the back closet, which is back there. This one actually sits right over here. So right in this part of my room, I have this hanging usually. And you could just use this and wipe up any of the broken glass that comes from there. And in the broken glass container, which I showed you in a previous video, you would put any of the broken glass in there. I actually don't have any broken glass in there right now, so that's always good. If you do get something on your hands, you should always wash your hands. Sometimes when we're working with something, especially if there is a little bit of an acid, even if the concentration's very low, you'll feel it'll start to like tingle on your skin. If you ever feel that, just wash your hands, you're going to be fine. That's the best practice that we can really do in this lab. And really all in life now, you should be washing your hands all of the time in order to prevent contamination and the spread of even chemical contaminants in our chemistry lab. If, of course, you do obtain too much chemical and you need to get rid of it, remember, you don't want to put it back in this jar, but the best place to put that leftover chemical is in the waste beaker. And the waste beaker will be found over in the hood, which the hood is right back there. So I have, I think, 3 beakers that are labeled in there as waste. And if you do obtain too much, or even at the end of an experiment, if there's something that we really shouldn't flush down the drain, you always want to put that in the waste beaker, and that's located in the hood. I hope that this was helpful. At this point, you can then go ahead and answer questions 1 through 4 in part 5 in your lab procedures packet. And as always, if you have any questions, you can make sure you ask me the next time you see me. Bye.